Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by TechStrong and SciCode. My name is Cody J. Brown, the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is recorded, so if you miss any of our discussion or you'd like to share it, the on-demand recording will be available shortly after we conclude the webinar today. If you have any questions for our speakers, we want you to direct those to the Q&A tab on the right side of your screen. And for any additional comments or just if you want to let us know where you're tuning in, that's where we want you to use the chat tab. Finally, at the conclusion of our webinar, we'll have a drawing for 4 $25 Amazon gift cards. So stick around to see if you're one of our 4 winners. But on to our topic today. Our panel is called Google SLSA and NIST SSDF, Emerging Software Supply Chain Security Best Practices. And I'm joined today by Ronan Slavin, co-founder and CTO of SciCode, and Tony Lower, developer advocate at SciCode as well. It is my pleasure to turn the floor over to them to get us started. Thank you both so much for being here with me today.
Thank you for the introduction, Cody. So today we'll be going through the Google SLSA and NIST SSDF frameworks. And we will be comparing these two frameworks. We'll also be covering gaps which appear within these frameworks. And Ronan will conclude us with a demo, and then afterwards we'll have a Q&A session. So the first question is, why do we need new application security frameworks? Well, attackers are shifting priorities. Rather than attacking production apps directly, we've seen a rise in software delivery pipelines and developers being attacked directly. Software supply chain attacks are on the rise. As far back as 2018, we only saw a few of them. But in the last year or so, we've seen SolarWinds, we've seen CodeCove, we've seen Kaseya, all of which have really rocked the security community. And by 2025, 45% of organizations worldwide will have experienced attacks on their software supply chains, which is a 3-fold increase from this last year. Now, the first framework that we're going into is the NIST SSDF. This particular framework was created by NIST in response to an executive order from the current administration. This coordinates several federal agencies to actually define standards for organizations to help them mitigate the risk of cyber supply chain attack. This President executive order will eventually be used to create criteria to evaluate a organization's current security posture, and it is furthermore going to help design and develop new standards, tools, and best practices to help enhance this software supply chain security. The development of commercial software often lacks transparency, sufficient focus on the ability of software to resist attack, and adequate controls to prevent tampering by malicious actors. These 3 factors combined have been the largest factors driving the need for this new framework. Now, this framework was initiated last year, and I believe a couple weeks ago, actually, was just completed. We actually just put out a blog post on the NIST SSDF version 1.1, which is the first/final iteration of this particular framework. And it has provided additional guidelines, including procedures to actually evaluate your organization's current cybersecurity posture. So one of these critical tasks that NIST has completed is defining critical software. It's met with the National Security Agency, the Office of Management and Budget, and the Director of National Intelligence to define these standards. A draft update is available on their website, and these guidelines will all be used to evaluate security measures. This is prone to rehashing what I just said. Another thing, or another key aspect of this, is the CSERM. Organizations are concerned about the risks associated with products and services that may contain potentially malicious functionality, which are counterfeit and vulnerable, usually due to poor manufacturing and development practices within the cybersecurity chain. cyber supply chain. These risks are associated with an enterprise's decreased visibility into and understanding of how the technology they acquire is developed, integrated, and deployed. This publication on cyber supply chain risk management, abbreviated CSCRM, applies a multi-level specific approach, including guidance on development of the strategy, which will help organizations improve their risk assessment. Let's see. The cybersecurity labeling for consumers, which is another critical task here, is designed to help organizations and consumers determine what the cybersecurity posture of the software they're using is. This labeling is designed to be extraordinarily broad in terms of its usability. Everyone from developers looking to implement a new dependency to end consumers will be able to utilize this particular software evaluation framework. This framework is designed to encourage innovation in manufacturers' consumer-oriented IoT and software security efforts, be practical and not burdensome, be usable, and build on experience. And most importantly, it will allow for a diversity of approaches and solutions across industries, so long as they're deemed useful and effective for consumers. What this last particular point looks like is determining what an organization's cybersecurity investment should be based on return for investment. If an organization doesn't do a huge amount of software development and software deployment, most importantly, it doesn't make sense for them to drop a huge amount of resources into boosting their cybersecurity posture. Conversely, if an organization does do these things, then it is imperative for them to invest as much effort as possible into their risk mitigation strategies. The baseline criteria for consumer software labeling includes the following aspects. It includes descriptive attestations, which simply describes the nature of the software in a meta sense, and also includes other details on it that you can see here. This is all designed to establish a baseline set of technical criteria to inform the responsibilities of consumer software providers and a software label. These ultimately convey good practices for secure software development during the life cycle of the software. Now, the NIST SSDF ultimately has 5 objectives. Objective 1 is to protect, which is to protect executive order critical software and critical software platforms from unauthorized access and usage. Objective number 2 is confidentiality, which is to say they want to protect the confidentiality, integrity, and availability of data used by this critical software and critical software platforms. Objective 3 is to identify software. And if anyone's familiar with the concept of software bill of materials, that is ultimately what this is describing. To those unfamiliar, a software bill of materials is simply a ledger of all of the software that an organization, or correction, that an application uses in order to complete all of its objectives. This includes its dependencies, etc., all the way down the chain. A huge benefit to this is also being able to identify what dependencies you're using in terms of what vulnerabilities may be present. A huge issue with the log4j vulnerability that everyone was talking about several months ago is the fact that it wasn't often an application was directly using log4j, but rather one of its dependencies or one of those nested dependencies was actually using log4j, thus introducing a vulnerability that an organization might not have even been aware of. Objective 4 is rapid response, which entails quickly detecting, responding to, and recovering from threats and incidents involving this executive order critical software and executive order critical software platforms. Rapid response also entails contingency plans. Objective 5, which I dare say is probably simultaneously one of the simplest yet difficult to implement, is training, which is strengthening the understanding and performance of humans' actions that foster the security of executive order critical software. This training really just entails informing your personnel and informing your developers of what good software development practices are. It often requires a bit more upfront investment by an organization, but it is the kind of thing that will ultimately pay off. Another thing that the NIST SSDF introduced is the risk severity schema. And this particular guideline helps provide the severity of the assessed supply chain risk associated with a given source or covered article, the urgency required for risk response, the seniority level necessary for coordinating or making a risk response decision, and the alignment created by this, which will help an organizational understanding of supply chain risk. It should also be noted that risk characterized as level 3 and above is considered substantial risk, thus requires mandatory information sharing. This mandatory information sharing is only per se required within federal agencies or other organizations, which this guideline was written specifically to, but it is highly encouraged for all organizations who utilize this framework to share information as a means of helping improve the security landscape broadly. Now, the recommended minimum standard for vendor or developer verification of code entails industry best practices. Static analysis and dynamic analysis, also known as SAST and DAST, are well-known and respected methods of vulnerability detection. Threat modeling helps identify key and potentially overlooked testing targets. And as we mentioned before, checking included software through a software bill of materials is also recommended. Most importantly, though, is fixing critical bugs that are uncovered and also introducing policy, which prevents vulnerabilities from reoccurring. So to sum it up, with the NIST SSDF, the key practices include preparing the organization, protecting the software, producing well-secured software, and responding to vulnerabilities. Let's see. Next, we have Google SLSA. Yes, salsa like dipping in chips. So SLSA is the supply chain levels for software artifacts, and the goal of SLSA is to improve the state of the industry, particularly open source, to defend against the most pressing integrity threats. Now, though this framework is per se designed for open source software, every organization can benefit from the guidelines outlined here. So SLSA also entails 4 levels, levels 1 through 4, and these correlate to higher levels of supply chain security guaranteed. Now, SLSA level 0, which is kind of a tongue-in-cheek way of saying that there are no guarantees, represents the lack of any SLSA level. SLSA level 1 means that the build process is fully scripted and automated and generates provenance, including metadata regarding how an artifact is built. This metadata is derived from the build process, top-level source, and dependencies. The generated provenance offers a basic level of source code identification, but does not protect against code tampering. SLSA level 2 means that the build utilizes version control and a hosted build service that generates authenticated provenance, which provides tamper resistance to the extent that the build service is trusted. Now, SLSA level 3 means that the source and build platforms adhere to standards that guarantee both the integrity and the provenance and the auditability of the source code. This significantly improves protections against build tampering versus lower SLSA levels, and also prevents certain classes of threat, such as cross-build contamination. SLSA level 4 is the highest level of SLSA. This entails a 2-person review for all changes, as that is an industry best practice for identifying issues, identifying malicious behavior, etc. and the build process needs to be hermetic for this particular level of SLSA, which ensures the provenance list of dependencies is complete. Reproducible builds are not actually strictly required for any level of SLSA, but they are recommended as they provide many auditability and reliability benefits, which helps give end users of the software a high degree of confidence that the software has not been compromised. Now, a key point to note with Google SLSA is it helps protect both the source and the build. There are a large number of points where the code can be tampered with or otherwise corrupted, and Google SLSA is designed to help prevent this within the development process. Now, there are 5 categories of SLSA requirements. Those are source requirements, build process requirements, provenance generation requirements, provenance content requirements, and common requirements. The Google SLSA requirements can be outlined as such. Going into these more specifically, though, with source requirements entail a particular repo being version controlled, which means every change to the source is tracked. There needs to be a verified history. The content needs to be retained indefinitely, and 2-person reviews should be implemented and enforced. Strong governance over the software supply chain is required to enforce these particular standards. And another note with being retained indefinitely is that that is only required at SLSA level 4, and there can be some exceptions for retaining material indefinitely. But the point of it is that there should not be force pushes possible, which can overwrite the changes that are in a repository. Now, build requirements entail having a scripted build, utilizing a build service, using an ephemeral environment that is provisioned each time the build is run, creating an isolated environment that does not take parameters, since these parameters can corrupt, of course, being parameterless, being hermetic, and being reproducible. As I said before, this reproducibility is not strictly required, but it is recommended, and builds that cannot achieve this goal must provide a justification for why this is not the case. Moving on to provenance requirements, we have availability, authentication, being service generated, being non-falsifiable, and being dependency complete as our requirements. Provenance content requires an identifying artifact, the builder, the source, the entry point, and all build parameters to be included. This also requires all transitive dependencies to be included, along with reproducible info and the metadata. This metadata usually is used to aid debugging and investigations. An example of provenance content is as follows. Let's say a builder download example 1.2.3.tar.gz, extracted it, and ran a command which resulted in a file with hash 5678. Then the provenance might look like this, as pointed out by this little arrow here. Now, there are other requirements for SLSA, which are common requirements. These are only required at level 4, but they're required to achieve the highest level of confidence that a build has not been tampered with. This includes security requirements, which, if you might see, actually does reference NIST guidelines here. This 800-53 is actually the minimum standards for testing. Let's see, and then access requires that all remote access be rare, logged, and gated behind multi-party approval, and only a certain number of platform admins may override the guarantees listed here. The key with these common requirements is oversight. Basically, no one user should be able to corrupt an organization's code single-handedly, and that is ultimately the goal of it all. One can make an argument that it is an extension of zero trust, but we won't get into that here. Now, the key learnings from the NIST SSDF and Google SLSA are as follows. NIST focuses on what, while Google focuses on how. Another thing that I really like saying on this is that NIST's is descriptive, whereas Google is prescriptive. The NIST SSDF is focused on defining minimum requirements for software use within critical infrastructure, particularly federally, whereas Google proposes a specific model for scoring this supply chain, focusing on improving security within the build phase throughout development. In addition, NIST SSDF utilizes tiers, whereas Google SLSA utilizes levels, and these both range from 1 to 4, with higher levels correlating to increased cybersecurity. However, higher tiers within the NIST SSDF represent increasing degrees of rigor and sophistication in cybersecurity risk management processes, meaning that an organization has put more effort into actually developing processes without being specific as to what those processes might be. Conversely, higher levels within SLSA represent greater maturity. Every level of SLSA acts as a milestone towards the eventual goal of achieving SLSA 4. In other words, Google recommends every organization achieve SLSA 4. Now, some key learnings from this, or some best practices that we might garner from this, include reviewing for hard-coded secrets. NIST recommends using heuristic tools to examine the code for hard-coded passwords and private encryption keys. Let's see. And additionally, we want to uniformly enforce security policy, which entails strong governance and authentication. SLSA and NIST both highlight the importance of establishing baseline security standards to prevent compromise. Within SLSA, this is defined under common requirements. This specifically is mentioned within access, super users, and security. The NIST minimum standards for vendor testing and security and privacy controls for information systems and organizations is explicitly referenced by SLSA as a means of improving strong governance over a system, and is imperative to improving the security policy enforcement within an organization. Additionally, organizations should detect and remediate misconfigurations that may pop up within their organization. NIST suggests configuration management as a solution to this. This helps maintain system configurations and inventories, which includes specific hardware, software, firmware, and documentation. In addition, enforcing security configuration settings for IT products helps prevent these misconfigurations from resulting in vulnerabilities. Additionally, organizations should seek to reduce code tampering risk, which SLSA recommends with 2 different categories of their SLSA requirements. That includes enforcing source requirements, and having a 2-person review for this reason is beneficial because it prevents, or it makes it less likely for code tampering to be merged without being caught by a developer, or worse yet, merged by a malicious developer. In addition, we have enforcing build requirements, which entails ensuring hermetic builds and utilizing code signing as means of reducing code tampering risk through the build requirements. Now, there are some gaps within these frameworks. They are complementary, but they don't cover everything that should be done to mitigate risk. Source code is at the core of any software company's intellectual property, or correction, source code is at the core of every software company's intellectual property. If it falls into the hands of attackers, the repercussions can be tangible very, very quickly. But neither NIST nor Google frameworks address this need. Ultimately, organizations need to be able to identify suspicious behavior and mitigate code leaks when they occur. The SSDF does suggest to have a contingency plan in place, and SLSA suggests preventative measures, but there are no direct guidance to actually identifying these leaks when they occur. So we propose defense in depth, which essentially aims to slow down attackers with each layer of protection, enforcing least privileged access across all DevOps tools significantly helps with this. This prevents a potentially compromised developer from having a huge blast radius that can affect the entire organization, and it localizes the breach. Hardening configuration is also a another thing that organizations can do. This entails changing default passwords, implementing strong version control policies, and using trusted component registries, verifying the integrity at every stage with a series of handshakes between each stage of the SDLC helps ensure that code has not been tampered with and that the build is still sound. Centrally managing policies through governances, I keep saying, helps enforce policies consistently across tools, teams, and phases of the SDLC. And importantly is to audit thoroughly and audit frequently. Organizations should not overlook the basics. It doesn't matter how many tools an organization has. If they don't use them, they aren't really doing too much. In addition, anomaly detection is something that every organization should implement. Anomalies and access regarding access grants are a key example of this, as well as anomalies in configuration. If say a developer is accessing a repository or pushing a commit both outside their working hours and from an unusual location, that should probably be investigated because that can be certainly defined as suspicious. Anomalies and commits, as I just described, entail deviations from defined workflows and can include commits for code that developers have never touched before. Anomalies in behavior, such as commits from, as I said, outside a user's normal working hours, peer review from non-developer accounts, and changes in work patterns for employees leaving the company can be identified as anomalies in behavior. With the Great Recession happening, there has been a significant amount of intellectual property theft reported by employees, or correction, by employers. It'd be weird if employees were reporting it. And it is imperative for organizations to mitigate this risk. That's all from my end. I believe Ronan has a demonstration of certain capabilities of Cycode's platform that can assist with anomaly detection and the requirements that I've listed before.
Thanks, Tony. I'll try to share my screen. In the meantime, if anyone has questions, so feel free to send them down the Q&A tab, so we can address them. So hopefully you can see my screen now. Okay, perfect. So I'll do a quick overview of Cycode. I'll focus on the area that Tony had mentioned, basically to understand how our platform works. So I usually like to start with this section over here, the integration page, where you can see the different integrations that we offer. The basic idea is that we connect to the tools that make up the software supply chain of our clients. Each of these tool has their own API that we use to analyze it and to receive notification on any changes within these tools in real time. And on top of that, we built our platform. So obviously, when we talk about the supply chain, it starts with the source control tools where you store your code and you manage the distributed work on it. Then you have the build tools that on certain events, they pull this code and they build it. Following that, after the build completes, you would usually have binary image or artifact that you would store in a container registry to sort of to maintain versioning and to allow distribution of these items. And then finally, you would have the cloud environment or production environment that pulls from these container registries, and this is the actual binaries that you would run in your environment. Aside from that, we have integrations that are more in the workflow related manner that allow our clients to sort of utilize the platform in a more convenient way and use the current stack that they have in the organization. So really, the core of the product is policy-based. We've divided our policies into the different categories that you see here, where this would be like the different layers of security that we believe that you should make sure that you take into account when you want to secure your software development pipeline. So we start with the access, where we look at access-related configurations and help you reach at least privileged access within the tools. It was something that was discussed when reviewing the frameworks. Then we move to insecure configurations, that are configurations that are within these specific tools and within each and every repository configurations. These are configurations that you should be aware of, you should monitor, and you should enforce consistent policies around them if you use different tools to make sure that they all adhere to the standards that you want. We have secrets detection, which is a pipeline problem. So detecting secrets within the different stages of your software development pipeline. Leak detection capabilities, infrastructure as code and cloud security scanning, and a general audit model. And I'll walk you through some of the violations that are more related to the frameworks that Tony covered. So I'll start with the access. Basically, in the access, we look at two main things. The first one is access-related configuration. So, for example, if two-factor authentication is not enforced for an organization, we can detect it. We can show it in the product, and we can also help our clients take action on that according to the integrations that they have within the platform. Then, in addition to having secure configurations, you would want to make sure that the privilege grants are according to a least privilege access, so only people that need access have it. So we analyze the access permission. If we detect permissions that are excessive, meaning if we see, for example, a developer that is not doing any commit, we would flag it as excessive permissions, and we would recommend to reduce it, again, to help you reach a least privilege within these tools. Then we have the insecure configuration that is sort of complementary to it. So we look at various configurations that are related to the repositories. For example, whether you enforce branch protection rules. Both frameworks talk about having code reviews. These are things that can be governed and controlled within the SCM, but you need to enable it on a per repository level. So we monitor this as well. We'll let you know which repositories are missing, and we can also help you with remediating this and creating this branch protection for the platform. Within these branch protections, there are more sort of fine-grained rules, whether you require reviews or if you're enforcing commit signing, whether you're disabling forced pushes, which is also something that is relevant to the frameworks. So these are also things that we can check. And if we detect issues in them, we can alert on the platform and again take action as well. And then even when you don't have these controls, still you would have privileged users within your repos that are permitted to do such actions. So whenever someone, for example, commits directly to a protected branch, this is something that we can detect and we can alert on. This would be like a violation of the branch protection controls, but it is something that the source code management platform allows, and we can detect and show it to you here in this section in this specific violation. Moving on, we have our secrets detection capabilities. So we scan for secrets across the entire across the tools that are connected. We assign tags to each detected secret. We do the scanning for the public activity of the developers as well to detect any secrets that might have leaked through that. And we have an aggregated view of all the secrets that were detected here within the platform. We also have an integration with the pull request mechanism. Try to switch to GitHub. So this is an example of a pull request. The idea is to detect secrets that are committed to code in the pull request workflow, comment it to the developer, make them aware of it, ask them to remove it, and allow them also to interact back with us in case they need to. So making this flow interactive for the developers. But basically, the idea is that we work on reducing the secret exposure through integrating with the pull request mechanism and working with the developers within their existing workflows. Then moving on, we have the leak section where we scan for potential code leaks, which might be then used to sort of do reconnaissance on an organization and understand the technologies that are used. And finally, we have an audit piece where basically it's many audited events, but then some of these events, they're starting to get some security aspects. So for example, if someone removes the branch protections, which we just talked about as a critical mechanism within the tools themselves. So we can detect this activity and we can alert to you whenever this happens, and we can let you take action. The same for if someone, if let's say developer commits to a repository they never pushed before, or things in that nature. So that's the overview demo. We have much more in the product, like workflows and the knowledge graph, that we'll be happy to show at a different session. Now we have time for some questions.
Awesome. So the first question that I'm seeing in our queue reads, tell us about the measures to be taken when cryptography security fix and advancement extended from a release to another release and working to be compliant with NIST.
I need to read again for a second. So you mean like that your the cryptography standards move between standards? That's at least what I understood. Maybe Tony, did you understand what's the question? I'm not sure I understood it.
Could we repeat the question?
Sure. So the question reads, tell us about the measures to be taken when cryptography security fix and advancement extends from a release to another release, working to be compliant with NIST.
I think as I understand it, it's asking what sort of cryptography standards should be implemented to comply with NIST guidelines, or how to make that fit within. The answer is NIST recommends certain like organizations to take certain measures to actually mitigate risk. However, the strategies that should be taken are ultimately up to the organization, as ultimately an organization is very much aware of its stakeholders, its risks, and every other detail. Ultimately, all stakeholders within an organization should be at least in some form of agreement as to the steps that should be taken. I'm not sure if that's what the question was asking, but
so we got a clarification, and it says the question is how to maintain the security framework with multiple software release cycle and NIST.
Okay, so to me, like the answer would be to have like if you the way I understand the question is if you're releasing frequently, like how do you make sure that you adhere to the security framework? So the idea is that you would want to use like automatic tools and things that can help you make sure that that you follow like these guidelines and that you don't deviate from it.
The best thing to do if you have a complicated release cycle is to use tools that can assist you with it. It's already difficult to keep track of, assuming an organization only has one repo, which pretty much none do. But assuming that's just one repo, there's already a decent bit to keep track of. When you throw in a bunch of different release cycles, it just becomes more and more apparent that additional tooling is needed to assist with conforming to the guidelines provided by NIST.
All right. So I'm not seeing any more questions at this moment. So I'm going to just read off our Amazon gift card winners and see if we receive any more questions in the meantime. So if you have any more questions, now's going to be your last chance to get them in before we close out today. So quickly, our 4 $25 Amazon gift card winners are Sahil P, Ingo A, Scott B, and Tomas Z. So congratulations. Keep an eye on your inbox to claim that gift card. And if you don't see an email, just check your spam folder. So I'm looking back through our chat and questions. I'm not seeing anything else. So Tony, Ronan, if you have anything that you'd like to leave for our audience before we close out, I'll turn the floor back over to you.
So yeah, so thanks everyone for tuning in. If anyone wants to have a deeper discussion on this, or you want to enforce these frameworks within your organization and need help, so feel free to reach out to us and our team. Tony, you wanna add anything left?
Yeah, just want to say thanks to everyone for coming. We hope that you got something helpful out of this, and we very much appreciate you being here.
Perfect. Well, I'd like to thank Ronan and Tony for taking the time to be with us and putting together this demo and this PowerPoint and sharing their expertise with us. So I thank you both for being here with me today.
Thanks for having us.
Thanks, Cody.
Sure, of course. Also, a quick reminder to our audience that the session was recorded. So following the webinar, you'll receive an email with a link to access the on-demand, or you can find the recording living on the Security Boulevard website. Just visit securityboulevard.com/webinars. I would like to extend our gratitude to Cycode for sponsoring today's webinar. And of course, my final thanks goes to you, our audience. We appreciate you being here with us today. Please take a moment to fill out our post-webinar survey, and we hope to see you at another future TechStrong Learning webinar.